Graph the equation by hand that has a slope of 3/4 and that contains the point 0, -2. So this problem gives us all the information we need to create a graph of this kind of equation. We aren't given the equation, but we're given some important information from the equation. We're given the fact that we have a slope of 3/4, and we have this point of 0, -2, which could be any point on the graph. But as we can see by the 0 that's here in the x position, we know that this has to be the y-intercept of our graph. Anytime we have a point where there's a 0 as the x-coordinate, that has to be on the y-axis, so that's going to be the y-intercept. So let's start off by plotting that point, 0, -2. So we're going to start there. That's going to be our starting point for our graph. Now, to use the slope, we have to be sure that we understand what slope means. Remember that the idea of the slope is it's this concept of the rise of the line over the run of the line. And in this case, they told us that the slope is 3/4. So that means I'm going to rise 3 units for every 4 units that I run. And running is the going back and forth, if you think about how you might run. So from our y-intercept, from this point that we were given, we're going to use the slope to find another point. We're going to rise 3. So from this point, we're going to go up 1, 2, 3. And then we're going to run 4. 1, 2, 3, 4. So when we rise 3 and run 4, that's going to take us to another point on our graph. Now, it's not a bad idea to do that one more time. To rise through, now for my new point, I'm going to rise 3, 1, 2, 3, and then run 4, 1, 2, 3, 4, and that would give me another point on the line as well. Now notice that these are all positive. So when we've got the positive, the rise means that we're going to be going up, and the run means we're going to be going to the right, because that's how we move in the positive direction on each one of those axes. Be sure that the top number of your slope is the rise part. That's how you go up or down. And then the bottom part tells us how we go left or right. It's very easy to get these turned around, especially when you're new to graphing. And so by actually writing down rise over run before you write down the slope, that can just be a really helpful reminder on your paper of what you're supposed to do. We now have 3 points that are going to be on our line, but we don't want to stop there. We want to graph the whole equation. And so that means that we're going to want to connect these using our straight line. So we're going to grab our straight edge. So here's the straight edge. And this is just like you would do by hand. You're going to take the straight edge and you're going to line it up with one of your points. And usually just kind of choose the one to the furthest left. And now you're going to rotate your straight edge so that it lines up with all 3 points. And all 3 of those points should be exactly on the same line. You don't want one to be slightly off. If you ever find that one of your graphs or one of your points is slightly off of your line, that means that you've probably made a mistake somewhere along the way in counting out the rise or the run. So now we can draw our line. I kind of have a magic straight edge that allows me to keep going straight even after my pencil leaves the straight edge. And once we've got our line in place, we're finished with that straight edge, so we can go ahead and get rid of it. So let's do that. It's going to get rid of this. And now the last thing we want to do is to be sure that we put arrows on our line, because that will indicate that this line continues beyond where I've graphed it. Notice that my line doesn't just start and stop at the points that I plotted. Go ahead, extend your line basically through most of the entirety of your grid and put those arrows at the end to indicate that this continues forever and ever. And there's the graph of the equation that we were looking for.